Hey guys, this is Mr. Gordon here with a video to help you guys get started on working on your projects today. So a couple weeks ago on the early release day, that Friday, we did a sample project with the United States Census data, and you guys made a linear scatter plot with a linear fit, the residual plot to go with that, exponential fit, and then the exponential residual plot to go with that. And we used that to determine that the exponential fit was the best fit. So the residual plot is just one of the three ways, because notice here it says you should reference at least three measures that help you determine the quality of the fit. This could include computing rates of change, correlation, coefficients, residuals, or other techniques you have learned in this course and other math courses. It must include a column calculated the predicted values for your data. So I wanted to dive a little bit deeper into that, specifically correlation coefficients. So little review from, nope, wrong thing. What? My internet page got exited out. Sorry, let me find this again. Had a great resource. Here we go. Okay, so the correlation coefficient you learned about in Math 1 is R, just R. And that is the linear correlation coefficient. So it only works for linear functions. So here's a visual from linear functions. If you had an R value of 1, that's positive perfect correlation, as you see over here on the far left. 0.8, high positive correlation. 0.3, low positive. 0 is no correlation. So the closer you are to 1, the stronger the correlation is, or the closer you are to -1, the stronger the correlation is. It's just a negative correlation. But that's for linear functions. The same idea still holds for r squared, which is the value that we want to use, because that works for any function, linear, quadratic, logarithmic, power function, whatever of the 5 types you try, r squared is going to work for that, whereas r only works for linear. So let's get rid of that and let's scroll down. The same idea still applies though. So as you can see, the coefficient of determination, r squared, is useful because it gives the proportion of variance of one variable that's predictable from the other. In other words, the coefficient of determination represents the percent of the data that is closest to the line of best fit. For example, if your r squared is 0.850, that means 85% of the variation can be explained by the relationship, whereas the other 15% would remain unexplained. So the closer we are to 0, the worse our fit is. The closer we are to 1 or 100%, the better our fit is, because that's saying 100% of the relationship is being explained by the model that we picked. So let's look at how that plays out in this example that we did last time. So you guys already know how to make this plot, scatter plot. You know how to make this row predicted population, actual minus predicted. We did all that last time. So you just want to right click on your dot when you either do add trend line, or if you want to go back and format your trend line. All you have to do where we click display equation on chart is click display r squared value on chart, and yours is going to look a little different, but you're still ticking the same box. Yours just going to show up like built in on the right side of the screen. So when I click display r squared value on chart, now I can see, okay, r squared is 0.9814. So 98% of the relationship between time and population can be explained by this linear function model that you see here. That's pretty good. But remember from the residual plots, this residual plot for exponentials showed that it was better than the linear. So let's see if the r squared value shows the same thing. So when I right click, format trend line, display r squared value on chart, look at that. Even better, 0.995. So 99.5% of the relationship can be explained by this exponential function versus only 98.14% explained by the linear. So the r squared value justifies that the exponential is better again. So now I have two justifications. I have the residual plot justifying why exponential is better, and I have the r squared value justifying what exponential is better. So it says we should reference at least three measures that helped us determine the quality of fit. So your third measurement could be a variety of things, and you just want to stay consistent. Your third measurement could be just a description of the visual fit, how well it fits visually, how many of the data points the line of best fit or the function of best fit appears to be passing through. So you could give a visual argument. You could also notice it mentions computing rates of change. You could also look at just the actual minus predicted row and emphasize that, which is a bit what the residual plot is. Um, but you could also just talk about how close each of these points are, the predicted to the actual data, and have a discussion that way. So those are some options there, but you definitely want to have your R squared for each plot. You definitely want to have your residual plot for each, and then you can go with a visual argument, or you can just dig a little bit deeper into the actual minus predicted row that you've created. So that will satisfy it. Now remember, if this was my project right here, I would only be 2/5 of the way done because you need to make a best fit plot for, you need to have 5 models. So 5 different regression options. So right now I only have 2, linear and exponential. For each regression option, you need a residual plot, you need the scatter plot, you need your R squared value, and you need these rows. So you're going to have to do this process for 5 different regression options. So right now I only have 2, so I would only be 2/5 of the way done. And then you just have to organize it into a presentation. So notice here, I've got other options. I did exponential linear. I could try logarithmic. You can try polynomial, different orders. Each order counts as a new option, so you just have to have 5. And for each of your graphs that you pick, you have to make sure that you create a residual plot and look at the R squared value, which remember is the coefficient of determination. So I'll leave this up here at the end of the video in case you want to read that a little bit more. Thanks, guys.